Just going to sketch the sine curve out in this question to begin with. Remember, it repeats periodically every 2 pi radians. Now, if I put, I'm just going to write a little list down. If I put k equals 1 in, then I would get as my term sine of pi over 3, and that is root 3 over 2. Sine of pi over 6 is a half. These are some values that you just need to know. And if I put 2 in, then I get sine of 2 pi over 3, and actually that is pi minus pi over 3. I get the same thing. Like I've just found these two values here. If I put in 3, I get sine of pi. I get 0. And then if I put 4, I'm going to get minus root 3 over 2, because this is just a reflection. And I'll get minus again for 5 pi over 3. And then for 6, I'm back to 0. And actually, it's then going to repeat. Okay, now what we can do is investigate the summation for different values of n. So I've got my sum now from k equals 1 to n. And I'm just going to be letting, this is also now going to be my value of n. Okay, so I'm kind of combining this table. So for the first one, I'm going to get root 3 over 2. Then I would get root 3 from here and root 3 from here. I'm just adding them together. So I've just added these three terms. Now when I minus root 3 over 2, I would go back to root 3 over 2, and I get back to 0 and then 0. And you can see it's when when n is equal to 1 and when n is equal to 4 that I get root 3 over 2. And it's going to then be for 7 that I get root 3 over 2, and it's basically going to be every 3 that I get root 3 over 2. So when n equals 1, 4, 7, 10, because of the periodicity of all these terms. So our answer is going to be that n has to be one more than a multiple of 3. When I did this question, I forgot the fact that we are subtracting at this point. Like I saw the root 3 and I thought, yep, it's going to be one more than a multiple of 6. I missed out the fact that we're subtracting and we also get root 3 over 2 here. So it's really important to make like another little column and just keep adding up the terms and just see what you get. And once you get this, you can see this nice periodic sum. It's going to just repeat like that as you add on, 12 terms, you're going to get to 0. If you add on 17 terms, it's going to be this 0 because that's one less than a multiple of 6 and so on. Hopefully that makes sense. D is our answer.